Today we're looking at linear functions or linear equations in slope point form. But first, let's do our warm-up. So I'm going to plot the point 3 comma negative 2. So I go over from the origin 1, 2, 3, down 1, 2. Okay, so I go ahead and plot that. Then it says I'm going to draw a slope triangle with a rise of 2 and a run of 3. Then what is the equation of the line? So going back, my rise is 2, my run is 3. So I'm going to go up 1, 2 units, and to the right 1, 2, 3. Place another dot. I'm going to go down, so negative 2 units, and then to the left. So negative and a negative gives me a positive. So I can see that I could keep drawing in different points on my line using my slope triangle. Okay. So I can see that my y-intercept is at 1, 2, 3, 4. So my if my equation is y is equal to mx plus b, then my b value is equal to negative 4, and the slope is equal to 2 over 3. So the equation to my line is 2/3 times x minus 4. Okay, now lines don't always go through the y-axis right at a whole number. And when that happens, I like to use the slope point equation to write the equation of my line instead of slope intercept. So that would be using a point and any point on the line and the slope to write the equation of my line. So for example, well, first off, okay, slope point form is written as y minus y1 equals the slope times x minus x1. X1, y1 is the point on the line, so any point on the line, and then m is the slope. So this is just another way to see it. The point is x1, y1, and the slope is the m. So let's go back to our warm-up. My slope doesn't change. Okay, so the slope is going to be 2 over 3. And now we get to choose any point on the line. Okay, I'm going to go ahead and choose this one right here. So I'll label it in purple. That is 1, 2, 3. 1, 2, 3, 4, 5, 6. So negative 3 comma negative 6 is the x1. Let's see, my x. Negative 3 comma negative 6 is my x1, y1. So when I plug this into my new slope point equation, is y minus y1 is equal to the slope times x minus x1. Okay, so y's we keep, and then y1 is negative 6, so I use the minus. Negative 6 is equal to the slope, 2 over 3 times x, minus x1 is negative 3. So a negative times a negative gives me a positive. So I get y plus 6 is equal to 2/3 times x plus 3. Okay, this is slope point form here. All right, slope point form. And I can tell usually that something is in slope point form because it has these like parentheses and the y is not by itself and the slope is multiplied on the outside of the parentheses. Okay. All right, so we're going to do a couple more examples. Write the equation of the line in slope point and slope intercept forms. So I'll show you how to do this. First, we need to get a point on the line. So you can choose any point. I'm going to go ahead and choose the one, this purple one. So from the origin, that's 1, 2, 3, 1, 2, 3. So the point is negative 3 comma positive 3. And the slope of this line is, I'm going to choose 2 good points on the line. Looks like the next good point is right here. So I'm going to count 1, 2, 3, 4, 5, 6. That's negative 6. 2, 3, 4, 5. So the slope is negative 6 over 5. So I'm going to start by writing my formula. Y minus y1 is equal to the slope times x minus x1. And the point is x1, y1. We leave x and y. So I'm going to go ahead and write y, then the minus. Y1 is 3, positive 3, is equal to, the slope is negative 6 over 5 times x minus, and then x1 is replaced with a negative 3. Negative 6 over 5 times the quantity x plus 3. All right, so this is slope point form. Looking at the equation, I can see that my x1 is not 3, it's the opposite of 3, so it's negative 3. Woo, negative 3. And my y1 is going to be the opposite of negative 3, which is positive 3. And my slope here, where the m is negative 6 over 5. So this is slope point. And now we're going to change into slope-intercept form. To do that, I'm going to start with my equation in slope point, and then I'm going to multiply in the fraction, the slope. So distribute equals negative 6 over 5x, and then negative 6 over 5 times 3 over 1. Multiply the tops, giving me negative 18 over 5. So I'm going to subtract negative 18 over 5. Okay, and then I'm going to add 3 to both sides to undo the negative 3. So I'm going to add 3, and then I'm going to write on the side here, negative 18 over 5 plus 3 over 1. I need a common denominator, so I'm going to multiply by 5. I get negative 18 over 5 plus 15 over 5, which gives me negative 3 over 5. Okay, so I get y by itself is equal to negative 6 over 5x, and then negative 18 over 5 plus 3 was equal to negative 3 over 5. This is slope-intercept form. I can see that the slope is negative 6 over 5, and the y-intercept is negative 3/5. So I'm going to check on my graph to make sure that that matches, okay? So we already know the slope is negative 6 over 5 because we counted our slope triangle. And then if I look from the origin down to where the line crosses the y-axis, it's not a whole number. It's between 0 and negative 1. So negative 0.6, it looks like this is about negative 0.6. It's hard to tell from a graph what the y-intercept is going to be when it doesn't cross at a whole number. So this is why we would use slope point, is to help us figure out what our non-whole number y-intercept would be. Okay, so we're going to do the next one. Okay, we need a point. So on the graph, I'm going to use this point right here. You do 1, 2, 3, 4, comma 1. That's 4, comma 1. So I'll write my point is 4, comma 1. And then I need my slope. And again, it looks like I'm tracing the line to look for where it crosses the grid line nicely. Looks like this next point down here is the next good point. I'm going to count from the bottom point to the top. So 1, 2, 3, 4, 5. So positive 5. And then to the right, 2, 3, 4, 5, 6. So I have a slope of 5 over 6. Okay, so slope point form says, I'm going to start up here. No, I won't. Y minus y1 is equal to the slope times x minus x1. So I have y minus y1 is 1, a positive 1. So y minus 1 is equal to the slope times x minus 4. That would be this value right here, 4. Okay, so just rewrite this. Y minus 1 is equal, oh, my slope is, forgot my slope, is 5 over 6. And it makes sense because the line is increasing, it's going uphill. So my slope should be positive. Okay, so I have 5/6 times x minus 4. Here, that's slope point. Okay, changing into slope-intercept, I need to isolate y. Now you know why we did all that work isolating a variable, huh? Okay, so to slope-intercept, we're going to distribute in the 5/6. So I get y minus 1 is equal to 5/6x minus, and I'll just do the work on the side, 5/6 times -4/1. I am going to cancel here. 2 divides out of 4, and a 2 divides out of 6. So I get -4 divided by 2 is -2, and 6 divided by 2 is 3. Now I can multiply straight across. So I get 5 times -2 is -10 over 3 times 1, which is 3. Okay, so I'm going to subtract, because a positive times a negative gives me -10 over 3. And then to get y by itself, we're going to add 1. Okay, so you can get a common denominator here, or I like to do it on the side. So we have -10 over 3 plus 1. We can rewrite 1 as 3 over 3 so that we have a common denominator. So 10, add the numerators. -10 plus 3 is -7. So -10 over 3 plus 1 gives me -7 over 3. So my equation in slope-intercept is 5/6x minus 7/3. Okay, this is slope-intercept form. The slope is 5/6, and the y-intercept, the v value, is -7 over 3, which is like -2 points, 2 1/3. So if I look at my y-intercept, I go 1, 2, and a little bit more. So going a little bit, a third of the way between -2 and 3. Okay, so this time you have no graph, but it gives you the point and a slope. So I'm like, oh, okay, my line passes through a point 2/5 and has a slope of 3. So the point is x1, y1, and the slope is my m value, is 3. So I'm going to write y minus y1. So since I'm given the point and a slope, I'm like, oh, I should definitely write my linear equation in slope point form, because those are the two key components I need to be able to write the equation in that form. Okay, so I have all the information I need to be able to write the equation of a line. So y minus y1 is equal to the slope times x minus x1. Okay, remember we replace only the y1, x1, and the slope. So I do y minus x1, or y1 is 5. So y minus 5 is equal to, the slope is 3 times x minus +2. So a minus times a positive gives me a negative, and then a 3x minus 2. You should notice that, I think you should probably be noticing by now, that if the value in your point is positive, in the equation it is going to look negative. So because in the slope point equation we have a negative sign, we're saying x plus the opposite of x1, okay, or y plus the opposite of y1. All right, so this is slope point form, and now we need to write our equation in slope-intercept form. So we do that by starting in slope point. I think I'll box that for you. Okay, so we distribute first, just like you told me on your explain it videos from last trimester. We got 3 times x times 3 times -2, which is -6. And then we're going to add 5 to undo the -5. So I get y is equal to 3x minus 1. And from here, I should be able to pick out the slope. The slope is equal to 3. So if I look at this, y is equal to mx plus b, and my y-intercept is the b value, which is -1. Okay, looking at the equation for my in slope point, I can see right here that the slope is 3, and then the point that the line goes through is the opposite of what's in the parentheses. So 2, and then the opposite of what number is after the y. So instead of -5, I go through +5. Right? So you should be able to get clues from seeing an equation in slope point, and then also when you're given information, being able to write the equation in these different forms. Okay. All right, another one like this. You should try this one. A line passes through the point 12, 3, and has a slope of 1/4. So a point and a slope, I'm like, oh, point, slope, point, slope. Oh, point, slope form. I'm going to use x1, y1 here. And then the slope is 1/4, so that is my m value. Okay, so my point again is 12, 3. The slope is equal to 1/4. So we start by writing our equation out. Y minus y1 is equal to the slope times x minus x1. Then we replace only the y1, m, and x1. Everything else stays the same. So y minus x1, y1, y minus y1 is 3, is equal to 1/4 times x minus 12. Okay, again, looking at this, I'm like, the opposite of -12 is +12. Okay, that's the x of the point. The opposite of -3 is +3. That is the y of the point. Then I look, the number that I'm multiplying outside the parentheses should be the slope. True statement. All right, let's go ahead and change to slope intercept. So starting in slope point, and we distribute. So I get y minus 3 is equal to 1/4 x, and then 1/4 times -12 over 1. And I can see that you can divide out a 4, whoops, a 4 from each of these terms. So we get factors. So 4 divided by 4 is 1, and -12 divided by 4 is -3. So then I multiply 1 times -3 is -3, and 1 times 1 is 1. So that is -3. So I'm going to subtract 3. Now we add 3 to both sides. Y is equal to 1/4 x plus 0. Or y is equal to 1/4 x. So that is my slope-intercept form. I can see that the slope is equal to 1/4, and I'm adding nothing, so b is equal to 0. My y-intercept is 0. Okay. All right, so now we're going to graph a linear function from point-slope form. Okay, so I have my equation in point-slope form. Remember, it's y minus y1 is equal to the slope times x minus x1. So I can pick out from the equation that the number in front of the parentheses is my slope. So I know the slope is equal to 2 or 2 over 1. Okay, the point is x1 comma y1. So again, we're going to look at x1 is 4, and, or actually, I'm going to do this a little different. We're going to be like, +4 should be the opposite of x1. So the opposite of +4 is -4. And then the -3 is the opposite of y1. So that should be +3. Okay, so the point goes, I always start with the point. So at -4, 1, 2, 3, 4, +3. And then I count the slope from that point. You do not have to count the slope just from your y-intercept. You can count it from any point on the graph. Okay, So my rise is 2. I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Okay, or down 2 to the left 1, down 2 to the left 1. Kind of sound like a robot. Down 2 to the left 1. Okay, there we go. So this is the equation of the line. It is okay to write your equation in slope point. Okay, sometimes it's actually more useful than writing your equation in slope intercept. Okay, all right, so the slope, again, y minus y1 is equal to the slope times x minus x1. So the slope is in front of the parentheses. That's 1/2, okay? 8 is the opposite of x1. So the opposite of x1, 8 is the opposite of x1. So the opposite of 8 is -8. 5 is the opposite of y1. So it's instead of +5, it's going to be -5. So I'm going to go to -8, 5, 6, 7, 8. Down 1, 2, 3, 4, 5. All right, from there, we count up 1/2. Up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. That one looks like it has a whole number y-intercept. That's okay. No worries. Let's do that better. Okay. So our equation looks like so. All right, and that is how we write the equation in slope point and graph using slope point. Thanks for tuning in.